This is Dr. Carroll, and this video is about exception handling. In programming, typically an exception is raised when something unexpected occurs. For example, trying to open a file that does not exist, writing to a file on a full disk, trying to parse the string 100 as an int, and lots of other things. The syntax for exception handling is to use a try and except statement. And so in the try block is where we put code that could either raise an exception, and we could raise it ourselves by calling a raise exception and then passing it some message, or what we more commonly do is call code that it could raise an exception. And then in the except block, we handle all other exceptions that occur. And so now the try block can have several different pieces of code in it, but as soon as an exception is raised, it stops wherever it is in the try block. It does not continue, and it jumps down to the except to see what to do. And so it could be in the middle of performing an addition, and if you were trying to parse 100 as an int and then you were going to add that in, it will stop right there. It won't do the rest of the addition, and it will jump down to the except. So let's look at the exception hierarchy there's more syntax here. We can have more than one except statement, but we have to specify what the exception is. So we could have a specific exception here, and that's going to handle all the exception one. In that block, we would write code to handle all of exception one. And as you could guess, we could have another except statement that says, okay, well, here's a different exception. We'll handle that one. And then the general one, without a specified exception, will handle all other exceptions. Let's look at the exception hierarchy to get an idea of what exceptions exist. There are lots of them. And here's the link for the documentation for that. And so it's a hierarchy. And so you may have seen keyboard input if you press Control-C, and most of them derive from exception. Arithmetic error, if we have a zero division error for trying to divide by 0. You might have come across the name error before. OS errors are common in terms of or what we use for like file exists errors or file not found errors. You might have already come across a type error or a value error, and there's a lot more. So now let's add in the finally blocks to the syntax. So given the same syntax before, we can optionally have a finally block, and that whatever code we put in the finally block will always execute. Whether or not the try was successful, all the code in the try block was successful, or if we jump to an except block, whatever the case is, the finally block will always execute. So let's see a complete example now. So here is some code that we're going to read in some numerical values from a file that the user specified and display their averages. What could go wrong with that? So let's just ask the user for whatever file name and open it for reading, and let's create an empty list to store all the values that we're going to read in from this file. Now, we can't guarantee that the file that the user specifies exists. And so what we need to do is when we open it, we put it in a try block. And then we have an except, and the error that we want to catch is an OS error. And so in terms of files and things like that, it's the exception is an OS error. And so then we can say, hey, we tried to open this, it didn't work. And then let's show finally here by saying goodbye. So whether we were able to do everything successfully or whether there was a problem, we're going to say goodbye and be nice and polite. Okay, so let's continue with the if it opens. So assuming it opens and it's going to continue in this outer try block, and we want to have a new try block because reading from a file might present some challenges. And so we have our try except here, and we'll even have a finally. And what we'll do finally is, since we're in the we're processing this file, if we started here, then we know we need to close the file. So let's go ahead and plan on that. So then let's read in the entire file and just split it up by spaces. So we can do that with the .read and store everything in entire file contents. And then let's remove the new line at the end if there is one. And then let's get rid of all the new lines and replace them with spaces. And then let's take all spaces and split them up. Now we need to do, because if there's multiple lines in this file, we need to just get rid of those lines and then make it so that they'll all just go into one-dimensional list here. We split it up. So this is expecting spaces between the values. And at this point, these values are still strings. And so let's report how many values we found in that file. And if things aren't working right, maybe we want to print the values. So now they're all strings, all these values, and so we need to convert them from strings to integers. And so let's go through all of the values, and we need to know the index of them. We can't just iterate by element, because we're going to an int and then reassign it. If we iterate by element, we're getting a copy of it, but we need to change the value in the list. Now this is almost right, but let's take off any new lines at the end. I think this is actually redundant with replace, but it won't hurt to take off more white space on the end than less. And so now, casting it to an int could raise the value error exception. So let's put that there and say, okay, hey, we're anticipating that we could have a value error exception. And if it does, report, hey, we found a weird value in this file, and we were able to parse through this many values. That'll help the developer or the user to track down what went wrong. Okay, this is really coming along. Okay, now remove so if we did have that error, we want to just get rid of the rest of the values that are all strings so that everything in the list is numeric. And so we'll do some slicing, list slicing, to say, hey, only get up to where we were, up to the problem one, but don't include it, and then reassign that to the values list. If we do that, then we can calculate the average simply as calling sum and length, because if there was a problem, we truncated it. If there wasn't, we went through all of them. And then we can print the average of how many values there were, and we can display it to one decimal. Okay, let's see that. Python, multiple examples. Okay, if I have a file random values.txt, found 55 values in random files, random values.txt, and the average of them was 49.9. So let's look at what is the contents of that file. I just actually wrote a Python script that randomly displayed 55 values from between 0 and 100, and so it's no surprise that on average they come out to be right about 50. And I thought, oh, why don't we do a different number on each line and just have it increase? And so that's what random values is. Okay, so I went in and changed one of them. Notice, haha, I changed 8 to 8. Let's run it again. But this time, let's give it random values bad.txt and see what happens. Please enter the file name. Okay, we did that. Found 55 values. Great. Oh, alert. Oh, remember, it hit that accept. Instead of crashing and saying, I don't know what to do, it hit that exception and said, hey, something bad happened. I was only able to successfully parse 6 values. 1, 2, 3, 4, 5, 6. It said I got 6, and so I'm going to report on what I can. And so 62.2 is the average of the first 6 values. Okay, this is good. Let's do it again. Okay, so now let's try and open a garbage file name. Okay, we don't even need the .txt. Oh, notice it just said, hey, error, I was unable to open that file. Goodbye. And notice it says goodbye every time. Goodbye here, and goodbye here. And so that's it for this demo of handling multiple exceptions. I hope you enjoyed it. Check out my other video in the exception handling series.